What's up everyone, and welcome to another Rust electrical tutorial. I'm Austin, and today we're going to be covering part 1 of a 3-part series on how to build the factory. I recently released a proof of concept video on the factory showing how it functions more or less. So if you haven't seen that, I'll put a link here. You can check that out before you jump in to see what you're getting into here. Also, disclaimer that this is version 1 of the factory, so it's very possible that I will be releasing updates, simplifications, whatever. But we're gonna go ahead and do it, make a tutorial on this version 1 anyway, so just a heads up on that. There might be changes in the future. And then real quick before we get started, some channel updates here. I'm expanding my content. I'm gonna be adding some Let's Play videos for Rust, Starfield, Fallout 4, Project Zomboid, just some of my interests to, further expand into this channel. And I'm looking to you, the community, to help me build this, give me some views, some feedback, likes, interact with us so that the algorithm knows what I'm doing. So obviously I super appreciate that. And, understand that I'm never going to stop making these Rust electrical videos. I love them. I hope you love them as well. All right, so we're going to get started here. And of course, as I said, we're going to be making the system control. That is, if you saw the original video, this room here. It is the brain of the circuit, if you will. It controls all the crafting modules, which will be a future video number 2. And all I've done is just spread it out a little bit, try to make it a little easier to look at. And we're going to start from the center and work our way out. This is easily the most complicated part, and even not that bad once we get going, as you'll see. So we're going to deal with power after this. I'm going to start basically from the blockers and timers up for now. And the first thing to notice is that each one of these is just 5 items in a stack. So we have a timer, a blocker to its left, a branch, and a splitter. That is like a unit, a package, if you will. You'll notice it's the same thing. We have the purple one, we have the green one, and we have the orange one. These are all the same, and they're just linked together here at the bottom, which we'll cover kind of as we go. So we're going to start with the purple one. From the timer out, it goes to a branch. You're going to set this branch to 6. It's always going to be 6. So this one's 6, that one's 6, that one's 6. And its branch out is going to run to the branch above it, which is going to be set to 4. Again, all of these will be set to 4. So top row of branches is 4. Middle row, bottom branches here is 6. And then the power out of that first branch is going to run to the block pass through on the blocker to its left always. And that is, again, always the same. Blocker to the left, blocker to the left. And then, again, as I said, the branch out is running this branch up here. Its branch out is running to the splitter. This is just a way to create a 4 output splitter. Power out 1, 2, 3. And you can think of this one as 4. So it's just an easy way to do that. So this is just running set to 4, like I said, to this splitter. And then its power out along with these power outs. These are all just running to any one of these 4 broadcasters. It does not matter. You can send any one of these outputs to any one of the broadcasters. It's just a team of broadcasters. So each one of these are the purple ones. These ones are the blue ones down there. The green ones are over there on that shelf, and the orange ones are down there. And so that's all you're doing. Once you have that set up to link these together, and I'll show you how that works, with this down here, you just have to connect it. It's a timer loop. So if I were to turn this on, and we'll cover that, and start running it, it's going to run, all it's doing is going to run each block for the allotted time on the timer. And then once it's up, it's going to shift to its left to the next one. There it goes. And it'll just keep doing that. And once it reaches the end, it'll loop back around and start the orange one again. So not really complicated. The way they are hooked together is pretty simple. The power out of the blocker is going to run to the toggle on of the timer to its left always. With the exception of this one, the power out of the blocker is going to run to the timer on its left, which happens to be way over here. That's the only reason that line is jumping back through. So it's just a big loop. It's going to keep doing that. And all you have to do is set it up the way I have shown. So if you need to pause it for a second and take a screenshot, now's a good time. Once you've completed that and you have all this from the timer and blockers up, and you have them connected to the broadcasters here, to each one, again, doesn't matter the order. The next thing you're going to want to do is power it, obviously. And so down here, I have, this branch here, and it says large battery. And the reason I have it say large battery is because you need 77 Rust watts to power this whole thing, which includes this stuff over here, which we'll do here in a minute. So the minimum, if you have a battery hooked up to this, that you need will be a large battery, 77% of a large battery. So I have that power out running, 77 on the branch. I'm sorry, not the branch out. The branch out, sorry, is set to 77, and that is running to this first block. And this is just a chain. These three, not this fourth one. This is part of this splitter. It's the same thing I did up there. It's just 4 outputs. These three are the power distribution. So I have this main branch. This power out here represents what's left. You could use this for other items unrelated to this from your battery. But so of the battery, 77 is going to go to this power distribution, and these are just power out to power in, power out to power in, like you normally would. And these three are everything you need to power this whole thing as far as like power distribution goes. So I'm going to turn this off really quick. So this first one here is set to 10. This first branch is set to 10. The second branch is set to 39, and the third branch is set to 18. And that's the breakdown that you need from that 77 going into these three branches again: 10, 39, and 18. The first one, the 10, that branch out is going to run to this first branch splitter combo to make the 4 outputs, just like I did up there. So that's 10 arriving here. The branch out is set to 7 because you need 1 to power it, and then I want 2, 4, 6 here. So 2, 2, and 2, 1 to power it is 7 arriving here. So 7, and the power out will automatically have 2 based on the settings of this branch. So as long as you set these correctly, if you set this one to 7, you'll automatically, or you should automatically get 2 coming out of this one. And all these ones are doing is powering the blockers. Each blocker needs 2 arriving. So that's a check. You should have 2 arriving at every blocker. It's 1 to power the blocker and 1 to pass once it's released to the timer to its left. So very simple. I just need 2 rust watts to each of those blockers, and that is what this is doing. So the next one, this purple line here, that's running over to this switch. It is actually a good idea to put this switch in here. This is how I turn on and off the timers. If you need to shut the system down, you want to shut it down by knocking power to these timers and not the other way. You don't want to hook it up to this one because every time you turn these on, it starts the timers at the same time, which we don't want. That's kind of a pain. So I have a switch set up interrupting the power going to this branch here. So whereas before I had this white line running to this branch, I've got the purple line running to the switch, and then from the switch out, I'm running it to this branch, and I just added an extra rust watt to this. So now this is 39. It would have been 38 without that switch. So the power out of that switch runs to the power in this branch. You're going to set this branch out to 28 specifically because we want 9 coming out of each one of these. So 9 should be coming out of each one of these outputs. So if you set this to, 28, this will use 1. You have 27 left over, so that's 9, 9, and 9. And then whatever's left over here, assuming you set this branch correctly here, you'll automatically have 9 coming out of here. And all these are doing, all of them are running to each of the timers, and that's it. Doesn't matter which timer you run them to, any order, you just need 9 arriving at each one of these timers to be able to power everything above it. So real simple there. And then this is just an on-off switch to cut power, because if they're running and something goes wrong and you want to restart it, you can just flip this switch, turn them back on, and then they'll be ready to activate. And that is literally all you have to do for this center spot. We've covered how to set up the blocks, how to link them together. You're going to connect them, each one to each of these broadcasters. If they're running, little checks you can do. You should have 1 arriving at each of these. Which actually, I forgot which one's running. This one's running. Little checks. You should have 1 arriving at each of these as they run down their thing, because you only need 1 to power. There they are. And you can check that right here. Each one, if it's live, should have 1 coming out of here. You can kind of do little checks just to make sure that you've set this up right. But if you follow the branch settings I did and the power settings I did, then you will be good to go. So the last piece on this here, before we get into the frequencies things, which I'll discuss here quickly, is this last branch here has 2 outputs because it's the last in my block, so I'm using it for 2 different things. The yellow line here is running all the way down to this, trying to get 4 out of it. You'll notice a pattern here. That is running to this branch here. This one is the one that's set to 18. And so this branch itself is set to 13 because I need 13 arriving. It's going to use 1, 12. We should have 4 coming out of each one of these and 4 coming out of that. So as long as you set those correctly, you'll automatically have 4 set this to 13, you'll automatically have 4 on each of these. And all these are doing is they're powering one side of each one of these RF receivers. And so you just need 4 sitting at the receiver so that when it gets past, which we'll cover in a minute, there's enough you need 1 to power it, and then 2 to get through, and 1 available to activate this timer. And that's just for these 2 checks, which we'll talk about here in a second. So set this up. You're going to run each one of these outputs to a receiver, to that power end of a receiver, 4 of those. And so you should have 4 with 4 Rust watts arriving at each one. The last part of the power one here is this power out here, which, because this is set to 77 and you set all these correctly, you should have a terminal 7 coming out of here. This is just running over to this branch here, which is then being used to power these 2 conveyors. So if you look at the branch out, it's set to 4. If you look at the power out, it should have 2 coming out, because you're going to have 1 arriving at this first conveyor, and then its pass through I have going to the second conveyor. So you just have 2 Rust watts, 1 to power this one, and then 1 to pass to power the second one. The 4 coming out of here, this branch that has 4 coming out of here, that is running up to this. I can highlight this. There we go. That's running up to this timer here. And it has 4 because we want 4 arriving here so that 3 passes. So that when we get here, we have 1 to power this. We have 2 left, which will send 1 out of each of these to turn these on briefly. So each one of these is set to go to the turn on, and this next one is set to go to this one's turn on. It doesn't matter which of these you use and send. Just send 2 of them to the turn on input on the conveyor. And then the conveyor itself, the last part you probably can't see, is that the turn off, the filter fail is sent to the turn off. So you want to send the filter fail to the turn off of each conveyor so that it checks. You'll see it's on for just 5 seconds, and then it turns off. And if you've watched the video on the factory, this is how the system checks. So just make sure that you have to set this up this way. Once we go farther in the tutorials and the crafting modules, I'll be actually hooking this up, and you'll see how it works. And that's it. So then the last part over here is that we discussed we have power here coming to the input. The output, the power out of each one of these, is going to go to one of the inputs on an OR switch. So you should have 2 OR switches, 4 inputs, 4 of these each going to an input. And then the OR switches are trunked together into another OR switch to bring them into a single output, which then runs to the toggle on specifically of this timer. And so that's why we need 4 Rust watts coming out of here, because we have 1 here, 1 to power it. It's going to pass 3. When you have 3 arriving here, 1 gets used, 1 gets used. You have 1 left coming out of here, and that's what runs to this timer, which is set to 0.25, because we're using it as just a quick, it turns these on so that they can run a check. There they go. They run a check, and then once they don't detect anything, in this case, they're going to turn themselves off. And that's literally all the power. I think I covered this, that this obviously, you should be able to see this runs to the top of there. But that's all the power. We've discussed all the different branches. We've discussed all the settings. And so now you have this system where in its default configuration, these will default to 10 seconds. We're not going to actually cover what to set these to, because that's going to depend. That'll be in the calibration video. You just have to have this working. So the last thing we'll discuss real quick before we just make sure that it's running the way it should be is the frequencies. And so basically the system needs on and off frequencies. And for the ease of a tutorial, I've made the on frequencies being 10, 20, 30, 40, and I made the off frequencies 11, 21, 31, 41. So just 1 more than the on frequencies. It's really important that you don't choose frequencies like 10, 20, 30, 40. You have between 1 and 9,999 choices of any any size of number. So you could have double digit, you could have triple digit. So there's literally thousands of opportunities. Use random number, maybe even use a Google random number generator. Pick 4 for on and 4 for off that are nowhere near the frequencies the game uses for oil and things like that. So just pick 4 extremely random numbers. It's incredibly unlikely somebody will also have these numbers for anything in the game while you're playing. And so what we're doing is each set, and so this is like, we'll look at the blue one here as an example. So this blue one is running to these 4. What you need, and so I have here in this sign, it says blue on, off, off, off. So it's 10, 21, 31, 41. So I need 1 on. Each set of 4 needs 1 on, and it can't be a duplicate of another on. So I have 4 sets of broadcasters. I have 4 on frequencies. So this one down here, the blue one, it has an on frequency of 10. It's this first one. It doesn't literally matter if you do it. I did it this way to keep the numbers sequential so that it is maybe easier to look at. It does not matter which one of these is on. All that it matters is that of the 4, 1 of them has an on frequency and the rest have off frequencies that are all different. So if I do this blue one was what? The on frequency was 10 I chose, which means the off frequencies are going to be 21, 31, and 41. I use 10 and then these 3 off frequencies. This pink one up top, it has the second, I used the 20 on, which means I'm going to use the 20 for the on frequency and then 11, 31, 41 for the off frequencies. And we'll cover why that matters later, but this is a critical part that it has to be done right. So the green one has the on frequency of 30. And so it's going to then use, if I'm using 30, I'm going to use 11, 21, and 41 as the off frequencies. And then orange, I have it as 40 is the on frequency, this last one, which means the rest of these, the off frequencies are going to be the other ones that are not associated with 40. So 31, 21, 11. And you can literally just see, I did them in order, 11, 21, 31, and 40. The green one was what, the third one? So off, on is 30 is the even number, off 41. And so I did that. And the important thing is that you can never use an on frequency twice. So you need to only have 1 on frequency per set of 4, and then the off frequencies are just whatever the one you use as an on frequency. Just make sure the off frequencies are the other ones that are, I would never use on the number 20 for on and then also use 21 in the same one, if that makes any sense. So you can just look at how I did these on these signs. This will become more clear later, but this is how the system is able to differentiate and shut down things that need to be shut down before a new loop starts. So I suspect that if there are potential problems, this might be it. So just choose your numbers carefully, write them down carefully, make sure that you know what they are, and maybe do something kind of intuitive just so that you can keep track of what you're doing. And that is literally it. I mean, this is the system control. This is the brain. This is what runs the whole show. And so as like a check, if you've built this, if you're testing this, an easy check here is to just make sure that it's looping. That's why I have this thing running. It's set to 10 seconds. It should just jump to the next one, run for 10 seconds, jump to the next one, jump to the next one, and start over. And as it's doing so, it should be initiating. So are we on the purple one? These ones are currently running. You can literally just hold a wire tool to see if you have power there. You could also set up receivers, which we'll go over there and take a look at those here in a minute. Actually, I didn't tell you guys what those frequencies were, but it's just going to keep doing this. So now we're on the 4th one. It's going to run for 10 seconds. Obviously, in the actual setup, you're going to set these timers to very specific values depending on what you're crafting, which we'll talk about in the calibration video. But for now, just make sure that it's doing this, that it's cycling down, it's powering. Each one that's powering is putting out the right rust watts, 1, 1, and 1 up here, right? You should have 1 coming out of here. The blocker should have 2 coming out. Just double check that it's giving you and doing what it's supposed to be doing before we move on to the next part. So the last thing that I just forgot to mention here was that these ones over here, these receivers are all set to on frequencies only. So we have 10, 20, 30, and 40. So whatever your on frequencies are, in my case for this demonstration, again, I just did 10, 20, 30, 40, you're gonna set these to those, because what you want is every time this thing cycles to a new block, a new color block, you want it to turn this on for 1 second so that these can scan and say, well, we'll talk about the calibration more, but you see how they turn on, and the next time we swap over, they're going to turn on again. And what's happening is just that each time a different one of these sets. So this one's 0, 0, and 0 because we're on this one right now, this particular one. As soon as it swaps over, it's going to be a different one. Let's see, we're on this one now. So we're sitting at the 41. So As each one of these runs its on frequency, it's going to swap among these, which allows for this thing to check, make a quick check, which will be discuss later. So that pretty much wraps up part 1 of system control. I'm gonna, stay tuned for part 2. We're gonna build the crafting module in the next one, and then I'm gonna build it literally right next to it, right over there. And then in the third one, we're gonna hook these together, and we're gonna set up some things to craft, calibrate everything, set these timers, make sure that it's running, and actually just do a demonstration of it running. So that, folks, is just about all I've got. If you have any questions or comments, you can leave them below. Otherwise, you can get me on my Discord. See you later.